Hi guys, so let's take a look at this example here in section 5.5. We have a rational inequality. When you look at this, it might be tempting to do something like cross multiply. That, however, isn't going to work. It's only going to get you part of the correct answer. What you really want to do is compare it to 0. So you need to get 0 on one side. So I'll do that by subtracting over the 3 over x plus 1 to the other side. Okay, so now we're comparing it to 0. What we really want to do is compare a single fraction to 0. So we're going to find an LCD between these two. They don't share any common factors, so the only LCD could possibly be is x minus 3 times x plus 1. So by using this common denominator, we can combine these into a single fraction. So I'm going to do that now. So the first one's going to get multiplied by x plus 1 over x plus 1. The second one by x minus 3 over x minus 3. Okay, so let me go ahead and write this in the next line. So I have 5 times x plus 1 minus 3 times x minus 3 over our common denominator, x minus 3 times x plus 1, and that is all less than or equal to 0. Of course, I want to simplify the numerator, so I'll distribute the 5 and distribute the minus 3, and then we'll see if we have any like terms we can combine together. Okay, and I have 5x plus 5 minus 3x plus 9 because I distributed negative 3. Okay, and so I have 5x minus 3x is 2x, and I have 5 plus 9 is 14. So I combine like terms. Okay, I'm also seeing that I could factor out this 2. It's not essential, but it will simplify the numerator a little bit as far as finding the 0. Okay, so now we have what we wanted, which is a single fraction being compared to 0. We want to know when this fraction is less than or equal to 0. So in other words, when it's 0 or when it's negative. We are looking at 3 different linear factors within this fraction, and they all are at 0 in different places on the number line. So I want to create a sign chart using the zeros, which will come from the numerator, and the undefined points, which will come from the denominator. So let's list them out first before we make that number line. So we have 1, 0, it's negative 7. Note that negative 7 will be included in the solution set because we have the or equal to sign. So when I make my number line, negative 7 will have a closed circle. We also have 2 places, or 2 x values that will cause this fraction to be undefined. Those are of interest because the linear factors in the denominator change sign, right, at these points. So it's going to be undefined at 3 and negative 1. So we will now make sure we put open circles on those. Undefined points are never included in solution sets. Okay, so let's make a number line. And we will label all these in order. So negative 7 will be first, then negative 1, then 3. Let's put some circles here. Negative 7 will be the only one that's included. Open circles here and here. Now I want to see how these linear factors change sign. I know where they are 0, and that is where they do change sign. You do have the option of picking test values within each interval if you want to do that. You can plug in numbers. You don't have to. You might be able to figure it out in your head. Either way is fine. So we're looking at x plus 7, x minus 3, x plus 1, and then the entire fraction. I'm not including the 2. The 2 is always positive, so the 2 is not going to affect the sign of the fraction at all. In fact, we could divide both sides by 2 and get rid of it. It doesn't really do anything as far as changing the sign. Okay, so then in this last row, we'll look at the sign of the entire quotient, right? It's a rational expression, so it's a division problem. Okay, so let's make a sign chart. X plus 7 will be negative over here. Sorry, I forgot the minus here. So it's negative over here, then positive, positive, positive. X minus 3 will be negative, 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 positive. X plus 1 is negative, negative, positive, positive. So now we can take a look at how these signs interact with each other. In an expression, if you have 3 negative factors, the entire expression will be negative. Next one, we have 2 negatives, so positive. 1 negative, so negative. 3 positives, so positive. So keep in mind that what we're looking for is less than or equal to 0, so where it's negative. So now I'm going to shade that on my number line above, up here, and right here, right, because it's negative here and here. So now I've shaded it so that I can make a translation into interval notation. So the solution set will be from negative infinity to negative 7, and I'm putting a bracket because negative 7 is included, union, negative 1 to 3, both with parentheses. Those are the undefined points. So what this is saying is any x value in here or here, when plugged into this original inequality, will give you a true statement. Otherwise it won't.